Hello everyone, today we'll talk about FSR sensors, mainly known as force sensing resistors. I will briefly cover what FSR sensors are, their history, how they work, and where are they commonly used. So first of all, an FSR is a polymer thick film (PDF) pressure whose resistance decreases as force increases. This, in these sensors, two interdigitated electrode pads are printed on one membrane facing a conductive ink layer on the other membrane. A spacer keeps them apart under no load, so when you press the active area of the sensors, the layers make contact and current flows. More pressures bring more conductive particles together, lowering the resistance. It is important to have to note that this behavior is highly nonlinear, roughly an inverse power law relationship between force and resistance. In practice, this sensor range go from uh, 10 milliohms with no force down to a few hundred ohms at high force. Now, the force sensing resistor was invented by Franklin F. Tough and first sold by Interlink Electronics in 1985. Earliest FSRs grew out of musical control experiments, and Interlink's 400 series were the original commercial FSRs. Franklin F. Duff founded Interlink to exploit his patent. Later, other companies, for example TechScan with their FlexiForce line, adopted similar FSR technology but with a piezo-resistive methodology. Over decades, the core idea, a polymer force-resistive sensors, have remained but have been optimized. Key milestones include the Interlink FSR 1400 series introduced in the 1980s and subsequent extensions. Well then, an FSR is built from two thin layers. One layer has an integrated electrode pattern, two comb-like traces, and a flexible substrate, and the other layer has a carbon-based conductive eve that is a resistive polymer. A plastic spacer with a hole keeps the ink layer from touching the electrodes when unloaded. So, when the force is applied, the spaces compress, letting the conductive ink contact the electrode traces over the active area. More forces make more ink touch more traces, so the resistance drops. For example, in the FSR 402 datasheet, so resistance falling from 10 megaohms to some 0.2-0.3 ohms as load grows. Importantly, the drops is non-linear. At low forces, the resistance is very high until a threshold is reached. Then it follows an inverse relationship, roughly R proportional to 1 divided by F as the power of K at moderated forces. Practically, engineers use a voltage divider or pull-up resistors or some amplifiers to measure this change. The FSR can cycle million of times, but it is not a precise scale. It's good for detecting touch percentages, not and not exact weights. Now, for the industrial applications, FSRs are useful in many fields. In automotive, FSRs detect seat occupancy, pedal force, or touch buttons. In medical systems, they are used in monitor patients' pressure, for example, bed, seat occupancy, infusion pump occlusion, or user input, for example, force sensing buttons. In robotics and automation, FSR serves as fingertips or grip sensors, enable grips for sensors and safety, differentiating a touch versus a grab, for example. Now, under a mat or in a raw finger, can find the center of applied force or detect presence of a load. So FSRs are also used in consumer electronics, touch-sensitive buttons, drum pads, game controllers for game industry, music industry, and even in network and health devices as force sensing insoles or equipment. They are low cost and thin-film allow embedding under surface or fabrics. However, due to their variability and high hysteresis, FSRs are chosen when simple enough or raw pressure feedback suffices, rather than high precision measurement. As I mentioned before, the original FSR was created by Intellect Electronics, whose FSR 14 series, Model 14, 14.2, etc. are standards in the technology. Interlink sells the 402 and variants, solder tabs, snap-on connections, etc. And another major supply is Texan. Their FlexiForce line uses a similar force-resistive design, but with a piezo-resistive sensor. Texan's FSR 201, 301, etc. are popular in research and medical sensing. Omite MFG also markets an FSR series of force sensing resistors, describing the same inverse force behavior as the Texan. Other makers include Sensitronics, funded by the original inventor, and Spectra Symbol, known for flex sensors and some force sections. Finally, for the pricing, an 402 section, for example, can be found about $8 or $9. There is kind of 13,000 pesos, or examples with $10 for about 44,000 pesos. And with other marks, for example, Texgain, a FlexiForce can be found in a price range about 35 to 37 USD dollars. That is about 150,000 pesos.